Hello everybody. So let's solve this problem, which involves finding the derivative of a function where inside that function we have an inverse trig function. Okay, so I think there's a lot going on here, but if we look at each rule that's involved individually, then I think you could learn to solve the same kind of problem. Okay, so I'm going to summarize it like this. I've got this function of the variable w. It is sine of cosine inverse of 2w. So right away I see composite functions, and I know that the chain rule is going to be involved to find the derivative. These are the rules that are applicable. First, I would have to find the derivative of sine of u, okay? And by u, I mean that in the chain rule, u is something more complicated. U might be a function of x, it could be a function of w, but it's some other more complicated formula. So when we write the chain rule and we say the derivative with respect to x of sine of u, we don't mean literally u. We mean you're going to see the u as being something more complicated, and the derivative is cosine of u, whatever that u is, times the derivative of the u, whatever that is. Okay, so this rule is obviously in play, but so is this one. You know, if you follow the first rule and begin working this, then ultimately you're going to have to say, what's the derivative of cosine inverse of 2w? Well, here's the formula for that, okay? The derivative with respect to x of cosine inverse of u is negative 1 over root 1 minus u squared times the derivative of u. Now, these are written in the typical way that we write the chain rule, where we're thinking the variable is x ultimately. Here it's w, but that's not going to change anything besides having a different variable. Okay, so let's begin with this. I would have to start this by saying, okay, what's the derivative of sine inverse of, or sine of u? What's the derivative of sine of u? That's the u, okay? So that would be, look at this formula, cosine of u times the derivative of whatever the u is. Now that's going to be like this, because I'm starting with sine of cosine inverse 2w. I'm looking at it this way. The derivative is cosine of cosine inverse of 2w, then times the derivative of cosine inverse of 2w. So that's our initial move here, okay? Where do we go from there? Well, I need to calculate this derivative of cosine inverse of 2w, okay? Let's just do that separately and then we'll come back. So, all right, what's the derivative of cosine inverse of 2w? Well, that's where this other rule comes into play. All right, so I see that in that context that the 2w is the u, okay? And playing that out, I get negative 1 over root 1 minus u squared times, what's the derivative of 2w? It's 2, okay? So there, I've used both rules. This problem necessitated that I use this one first, but then as a consequence of using this one first, I have to use this one to take it the rest of the way. Now let's combine what you see here and what you see here, okay? This part goes right there, okay? And we're looking at this. All right. So usually when we get to this point in a calculus problem, we consider that, okay, I've got my answer. Like this is the derivative right there. That is it. But it's another issue that we might be able to reduce this. We might be able to cancel things, simplify it, generally make it have less stuff than you already see there. So let me talk about how you can calculate cosine of cosine inverse of 2w. It might seem that the cosine and cosine inverse would cancel each other given that they're opposites. And I guess that is true here, but I want to consider working this out in a way such that if you got sine of sine inverse, that you could solve it, all right? So hear me out. Now what I'm about to show you is a lot like this problem that I've already made another video for, okay? So I want to go through all the steps, even though it may seem a little unnecessary, to figure out what cosine of cosine inverse of 2w is. So first of all, cosine inverse of 2w is an angle. That's what the inverse trig functions are. Sine inverse is an angle. Cosine inverse is an angle, so on. But specifically, it's the angle that has a cosine of 2w or 2w over 1. Cosine inverse of 2w is the angle that has a cosine of 2w. Since cosine is adjacent over hypotenuse, we'll say it's 2w over 1. Now, what would that angle look like if it has a cosine of 2w? Can you visualize an angle that has a cosine of 2w? Let's stick that angle right there, get a right triangle. Cosine is adjacent over hypotenuse. That means this side's 2w, this side's 1. If you want to solve for that side, it's root 1 minus 4w squared. So cosine of cosine inverse of 2w ultimately is cosine of that angle right there, which is adjacent over hypotenuse, so 2w. Now remember I said that you might think it looks like those are going to cancel and you're just going to get 2w, and that's true, but I wanted to solve this in a way that if these were mixed, if it was a sine and a cosine inverse, for example, you could still go through this reasoning to solve it. Okay, so I get a final result like this. That reduces to 2w. I get 2w times negative 2 over root 4 minus w squared. Multiply that, negative 4w over root 1 minus 4w squared. So there's our answer. That's our derivative. Now, there are lots of aspects to this, as is the case for many calculus problems. There's knowing the rules. There's knowing the order to apply the rules and how to apply the rules. And then, as is the case for almost any problem, there's the simplifying of the result. Okay, so I'd say this problem is typical in all those aspects. That we got rules, we got their applications, we might have some algebra or trigonometry to simplify. But in any case, that's it. Now, I encourage you, though, to reference this also, because the thinking in this other problem right here that I've already made a video for is what shows up right here. And I don't want to gloss over that or make light of this part. So if you need some further understanding of that, look at that other problem, and otherwise you can ask for help.